Thank you. Good morning. I'm sorry I cannot speak Russian. I would like to, but I can't. I will try, in my short talk, describe some of the lessons that I have learned during my 35 years of experience in this domain. Data science is relatively a new domain. I mean, the name exists, I think, for no more than about 6 years, but all algorithmic work and data mining is already with us for a long time. So let's start. I'd like to walk you about some best practices that I want to share with you that in my experience, most data scientists, when they start to do a job, usually they run fast into the data and to the models and to the different algorithms, and we are passing some important steps in the way that will enable us to really make an impact. So that's how I think it should be done. When you start a problem, try to understand exactly what is the objective, what you are trying to solve, and do it in a business manner. Understand with the stakeholders, with the business stakeholders, what are the right metrics that you are going to improve and how we are going to measure them. Then, this is done before you look at any specific model and any specific data. That's the first step. Then, analyze the data that is available for you. What are the sources that you have? Usually, there are some internal data that you have. There are some external data that you can bring up from outside sources. Sometimes it's free, sometimes it's not. Not necessarily the external data is important. Usually, you can get very good results with what you have, and you want to have results as soon as possible in order to validate the approach before you dive into further details. So when you look at the data, do you need the additional data? Is the data that you have consistent, or you have sources that conflict one another? And is the data coherent? Coherent, I mean that, let's say you are trying to model events that will happen in the future. You are trying to see whether my data at a certain point predicts that a certain event will happen in the future. So you're building your model on a stream of events, and you are trying to assess them on a timeline and understand what happened before and what happened later. And there are many flaws in such analysis that can create a data set that events from the future will be considered as events from the past, and this way might mislead you totally from the objective. So that's what I mean, is the data coherent? I saw many flaws in this approach as well. Sampling. Sampling is something data scientists sometimes refer not to do, because the claim is, I have more data, that's better. Well, is it? When you have more data, it means that your runtime is longer. It means that you invest a lot of time in every specific run of the model. And sampling, smart sampling, can reduce significantly the time that you will spend in analysis. So consider sampling. It's a very important tool that can help you. Accuracy. Accuracy measurement, there is external and internal. What do I mean? External is what you do in front of the business stakeholders. The business stakeholder doesn't understand what is AUC. They don't care about it. It's not important. You need to measure the accuracy in terms that the business understands, and usually you will need a test to measure this at the end of the day. But there is also internal metrics that you can use and you should use to evaluate your modeling when you develop them. Okay, now we are starting to work. We have the data. Before you run and build a model, which is sometimes you are eager to do, you want to see results. And this is not the best practice, because usually the results that you will see are not the right results. So look at the variables that you have, examine them one by one, see whether you have missing values, how do they distribute between the target variable and the non-target variables. See the correlation to the target variables. Sometimes you will have a lot of information there about incorrect data or hints about variables that you should use or methods that you should take, insights about the problem. So there's a lot of information there. And distribution of every variable against the target variable, the variable that you are trying to predict. That's very important because this will help you to create the right features for the model that you are going to use. Correlation is part of it as well. Okay. Accuracy. Well, usually the term is we need to be as accurate as we can. Should we? Well, it depends. In many cases, you can get a very good accuracy by investing very little. And you can invest a lot more to improve the accuracy a bit. Now, in some cases, the accuracy is really very important. There are some businesses, for example, algo trading or the ad agencies that are trying to predict and bidding for impressions in order to bid them. For them, accuracy is very important. But for most of other use cases, the accuracy, if you improve the accuracy by 1%, it means almost nothing. And you will need to invest a lot there. So try to understand what is accuracy that is good enough and move on, because there are many data science projects that you can do, and you better invest your time in what matters. Here, as an example, maybe the most known data science competition, the Netflix challenge. Netflix is a video on-demand supplier in the US. They have many users, and their claim to fame is that they know what the user wants. They can predict what you as a user would like to see. What contents do you like and what you don't. And they have built predictive modeling for that. And eventually they came up with a challenge. They said, we are opening our data, certain data sets to the world. Come and compete with our algorithm and show us that you can do better. And if you can beat our algorithm by 10% at least, you will win a prize of $1 million. Many teams were formed to compete in this. They tried a lot of algorithm, a lot of ensembles, a lot of work was invested there. And this is the leading board, eventually. You can see, number one that won the prize had 10.06% improvement. Number two came with the same accuracy, but they submitted their solution 20 minutes later. See, that's why they didn't win the $1 million. And number three is 9.9, number four is 9.4. So if you come number 8, you are only 0.5% below number 1. That's all. And that's usually the margin that you get by investing a lot in algorithms. As I said, in most use cases, it's not needed. In some use cases, it might be helpful. So know your problem and decide where to stop. When you are trying to analyze the data, that's an example of when you try to correlate your variable in the target variable. If I look at this graph, there are 3 points that are suspected to be outliers. Now, maybe they are not. What I suggest you is look carefully at these points. Sometimes you will find that they are not outliers and they give you a very good story or insights about the problem. Sometimes they are outliers. You know, at the beginning of the 20th century, the physics world, the understanding there was that we have solved almost everything. We know exactly mechanical, thermodynamical, everything is solved. There are only a few problems that does not really match to what we know. That was the notation there. And then from these few little problems came up quantum mechanics and relativity the relativity theory, and all the rest is history. So these outliers might be not outliers, but hints for the right problem or the right solution.
I'm sorry, do you have an example of that?
I have, but I don't have now the time to convey it. Let's talk and I'll show you. Okay. We are data science, meaning data and science. Don't run into speculation unless you have data to support it. It's okay to hypothesis, it's okay to speculate, but validate your assumptions and speculation with the data. Don't use just intuition. And when you solve the problem, usually when you run into a solution, you assume several things, and it's not very clear whether these assumptions are good or wrong. So you better state the assumptions clearly before you run into the overall solution. As I said, data science is a relatively new profession. If you are trying to be experts in data science, there are usually in position in the market, there are three typical positions, I would say. One of them is a data scientist that is all around, usually in startups like this. A data scientist that is on top of his work as a data scientist is writing code for several other projects as well. That's something that you might find interesting, but in the long term, this will not bring you to be top-level data scientist. The second type of position are companies where they have engineering and they have a data scientist. The data scientist is writing models, whether in R or whatever, and then he delivers them to the engineering to deploy the models at the production environment. There are solutions like this. Personally, I don't feel this is the right way to do, because this means that you are apart from the data. You need someone else to bring you the data. You need someone else to take your model into production. You don't own the model in production. You don't own the complexity of deploying the model, of the data model, etc. So I don't think that's the right way, but there are many companies who work like this. And there is the third model, where data scientists are also writing code. When they develop an algorithm, they write this algorithm into production systems, and they are owning this code in production system. Now I'll talk about WIX, my company. WIX is a company that builds a platform where people can build their website. People can manage their online presence. I'll skip now about this movie. Some numbers about WIX. It's a public traded company. Market cap is $3.5 billion. It's an Israeli-based company, although we have presence all over the world, and including in Kiev and other locations in Ukraine. Company is growing by 40% a year, which means a lot more data, a lot more opportunities, a lot more people. We have over 100 million users, over 100 million people who are using our platform. This means a lot of opportunities for data, a lot of opportunities to practice data science. The company includes about 1,600 employees, out of them 600 engineers, and our engineering part is very strong. We are writing in Scala, and we have a continuous deployment, if you're familiar with it, which enables us to deliver code to production pretty easy and fast. Some data points. So I said 100 million users. Every month we accumulate 2 million users, 2 new million users. 700 million events, in fact, more than this. We are collecting in our systems every day. We use, which are 1 terabyte of data. We are running A/B tests quite often. Every day you have dozens of A/B tests running to measure, because we are a data-driven company, and we have lots of data science problems, and we have also lots of data scientists. What is data science in WIX? What are we doing? We have a very strong team with very experienced people on top of it. We have 7 data scientists today, and we are increasing the team to more than 10. And I'm talking only about data science, not about engineers. We have on top of it engineers, although the data science are engineers by themselves. Use state-of-the-art technologies. We have collaboration with Google Machine Learning and with Amazon Machine Learning. So we have good opportunities to practice with them as well. Strong R&D that back us. They give us backup for our solution. And we are focusing on deep learning for vision mainly and for design. We focus on natural language processing. We have several problems in this domain. Classification, optimization, many data problems. As you can expect, we have a lot of data. We have a lot of data scientists, and we are having a lot of data science problem. And we are hiring. So if you think that you want a career in data science, you should consider WIX as an opportunity. I think you will not be, you will like this. Okay. Thank you very much.